Now, this is what we have to come back to. I is the square root of negative 1. I is a radical. And remember, when we were rationalizing the denominator, what did we do? We multiplied by who? What is he called? Begins with a C. Conjugate. Okay. Remember, that's what kills that denominator, because if you look at this becomes 1, inner outers add to 0, minus 5. So this denominator becomes minus 4. Now, if I'm going to divide something like this, I is a radical. It's as though that denominator instead was 4 plus the square root of negative 1. There is a radical there. So if I'm going to do this, it's going to act like the ones we did that didn't have the i's. You're going to need to use the conjugate, so that when I look at an expression, 1 minus 2i, its conjugate would be what? 1 plus 2i. And if I looked at minus 5i, what would his conjugate be? Positive 5i. And you say, well, why? Because this is 0 minus 5i. This would be 0 plus 5i. So in order to divide complex numbers or imaginary numbers, you need to use the conjugate. So here we go. Here I have 4 plus I. I need to multiply by what? 4 minus I. Now I'm going to leave the 3 outside to see if something reduces first. So 3, 4 minus I over 16, inner outers add to 0, minus I squared, and I squared is negative 1, right? So this becomes 3 times 4 minus I over 6 minus a minus, 16 minus a minus 1 is 17. Nothing's going to come out of there. Now, I don't have any problem with that answer, however, your book would. They wanted an A plus BI form. What I would do, if that would be a 12, I would have reduced out that 3. Now, the nice thing about this guy, if you're going to put him in A plus BI form, don't have to do that. But this would be, I have to multiply this through, 12 minus 3i divided by 17. So that A plus BI form is 12 over 17 minus 3 over 17 times I. Now the nice thing is if I still would have multiplied that 3 through, right, and if I divide by the denominator, if there was a common factor, it would have reduced out.
So we can keep that answer, the first one that we got?
Well, I would ask you to put it in, this is one of the few I ask you to put in A plus BI form.
Okay.
Just for the heck of it. It would be a major disaster if you didn't. Now, I'm going to multiply this guy by what? 2 minus I. So this becomes 5i times 2 minus I all over 4 minus I squared and we know that I squared is negative 1. So this would be 5 times, and let's take this out of there because let's multiply a sucker through. so you can see it.
It reduces.
It does reduce. And what she's saying is this, is I'm going to come up with 5i times 2 minus I all over 5. So the 5 actually reduces out. So I have I times 2 minus I, or 2i minus I squared. And we know I squared is minus 1. So this is going to be 2i plus 1. And there's nothing wrong with that answer, but it's not an A plus BI form, because your book is going to make you write it that way. 1 plus 2i would be the proper form. Okay, 5 plus I over minus 4i. What is the conjugate I'm going to multiply by? Just 4i. This is more than one term, so that's in parentheses. Denominator is negative 16i squared. The numerator is going to be, I'm going to multiply through by the 4, so that's going to be 20i. Plus 4i squared. Don't have to, could leave that sit out front. But we know that I squared is negative 1. So this is 20i minus 4 all over positive 16. And there's absolutely nothing wrong with that answer. But that's not what the answer the book would give you. So this would be minus 4 plus 20i, and both of them are now going to be divided by 16. So I mean, if you don't reduce it, and you get down to this point, you can reduce it. Which is minus 1 over 4 plus 5 over 4i.